Okay, so next example before we proceed to the next lesson. This is not in the slide, so I just give you extra example. Okay, here describe the domain and the range, and actually I also want you to then sketch the domain. Okay, so now look at about the domain. The domain is the set of x and y. X, y are real numbers, and you can see that they have a constraint here, right? So we have 64 minus 4x squared minus y squared always greater and equal to 0. Okay, and then the range is the value of z is real. And okay, now do we have the interval, some interval of z? Again, as I mentioned before, if your expression, even though inside of the square or outside the square root, or even in the logarithmic function, as long as there is a standalone constant value here, so there is a possibility. I'm not saying all the time, but there is a possibility that value will give interval of z. Okay, then you have to check whether the interval exists or does not exist. Okay. Okay, now to analyze that one, so I just copy the z function, minus 4x squared minus y squared. Okay, so now we focus first the value inside the bracket, this one. Okay, we have 64 minus 4x squared minus y squared. So now we want to see what is the possible value that can we have only for the value inside the square root. Okay, so here we can rearrange this. We can factorize the negative 4x squared plus y squared. Okay, now before we proceed to evaluate the square root function to get the z, now we look at the value, the possible value in the bracket. This way. So now can we see something about the pattern of the value in the bracket? So you can see that 4 plus 4, then you have x squared. So for this term, whatever value of x that you put in, the value always positive and can be 0 as well. If you put 0, then the answer here is 0. And similarly for y, whatever value of y that you put, negative, 0 or positive, and the value of the second term also always positive. So positive plus positive, and the total value of this inside the bracket always positive. So now if this one always positive, then we can put the smallest value is 0. So 0, 1, 2, 63, 64, 65, 100. Okay, and you can list many more numbers, but we don't want to waste our time. Okay, as long as you can see the pattern, so it's okay. All right, so now by taking all the value that we can have in the bracket, now we want to compute for the z. So remember the z here, there is square root. Okay, now let's say you choose the first one, 0. So okay, so your z, 64 minus 0 will give you 8, right? Because square root 64 is 8. And then when you choose 1, so now look at what happened to the value. 64 minus 1, and you got a smaller value, which is square root of 63. It should be smaller than 8. You can check. And then keep going. So okay, I just keep the 2, and I'm just using 63. Okay, remember you can put any value in between, yeah, not only this specific value. Okay, so z square root of 64 minus 63, and you have smaller number, right? Which is 1. Okay, and then when you put 64, where you have the value in the bracket is 64, so your z value becomes 64 minus 64, and you got 0. Okay, and then if you put 64.1, 64.9, and then 65, so 65, and then your value of z become -1, the square root of -1. Oh, sorry. 64, sorry, square root of -1. So you will get does not exist. Similarly, you put 100, you put 200, 1,000, million, and the answer keep to be does not exist. Okay, as we discussed on the previous example, we only want the answer or the value of z is a real number. So that is only the possible value of z that can we have. So we can obtain that z is only lying between 0 and 8. So that is the interval of z. Then you can put the interval into your answer here. So z is between 0 and 8. Okay. So we done that, and then we want to sketch the domain. Okay, in sketching the domain, we have to look again at the description of our domain here, and we take out the function that we have. So now we want to sketch. So 64 minus 4x squared minus y squared greater than or equal to 0. And when we rearrange, we have 4x squared plus y squared smaller than equal to 64. Okay, so now this is your new form. Okay, but then again, in order for you to sketch the domain, you have to know what is the standard curve. Okay, because when you want to sketch, you have to have an idea what is the shape, whether it is a hyperbolic, whether it is quadratic, whether it is a line, a straight line, or whatever. In this case, what do you think? Okay, you have to know the circle equation. For the circle equation, this supposedly the constant here should be the same, but now you have 4 and you have 1, so they are not the same. So meaning that this is not circle. For hyperbolic curve, one of the term should be negative. Okay, but this one they are all positive. But you have to remember we have another one, ellipse. So ellipse is just like circle, but the constant here are different. So it looks like we can have ellipse, but for ellipse function, this one should be equal to 1. Then you have to modify. So 4x squared divided by 64 plus y squared divided by 64, it turned out to be 1. Okay, but this one for ellipse, this one supposedly 1x squared. Then you have to divide this one by, divided by 1 over 4, or you can simplify. So you can have x squared over 64 over 4 plus y squared over 64 less than and equal to 1. So we have x squared over what is 64 over 4? We have 60, right? 16 plus y squared over 64 less than and equal to 1. Okay, and this is an ellipse, but in order to sketch an ellipse, you have to ignore the inequality. You have to assume this is equal to 1. Okay, so in sketching the ellipse, here it's just like a squared. So a tells you the length on the x-axis. So if your a squared is 16, so your a is 4, right? So meaning that the thing that you have to do is you have to rewrite into a general form of ellipse. So 4 squared plus y squared over 8 squared equal to 1. So I just ignore the inequality first because I want to sketch the ellipse. So it looks like the length on the y-axis is longer than the length on the x-axis. So the length on the y-axis is 8 and the length on the x-axis is 4. So 8 and this one 4, and this one minus 4, and this one minus 8. And then you sketch the ellipse. Okay, that is your ellipse. Okay, that is sketching on the not yet, we haven't done yet because we have to shade the area. Okay, how can we know which area that we need to shade? Then you have to look at the inequality here. We have a closed curve and you have equal to, meaning that you must sketch a solid line, and then smaller than, meaning that inside the ellipse. So that is your sketching of domain. Okay, so how can you relate this again? How can you, what is the reason why you need to sketch this? So this one is explaining your description of your domain here. You want to say that, okay, I can choose any value of x and y as long as they are inside the ellipse. But if I choose outside the ellipse, then the z value here does not exist. So you can check. So let's say you put a value 0, 0. Okay, the simplest one, 0, 0 origin. Or you can choose 4, 0, or you can choose 0, 8. And I can confirm that the value of z exists. However, if you choose, let's say, the value of 4, 8 here outside the ellipse, then I'm very sure that the value of z does not exist. Again, please check. Alright, so hopefully clear with this about the domain range and sketching on the domain.